Picture this. Me and my family went to the park to enjoy the wonders of a blistering summer heat, or mostly just play with frisbees. Unfortunately, we weren't very good at it. At first. Eventually, we got used to the throwing and aiming and managed to pass it back and forth, for the most part. While we were all goofing around, a question popped up in my head. But let's backtrack a bit. So what are vectors and scalars? Well, vectors are quantities that describe both direction and magnitude, while scalars are quantities that only describe magnitude. Now let's just say I'm a dot on a plane. I pass the frisbee 10 meters east to my brother David, who then passes it 6 meters north to my sister Hannah. Now how far and in which direction did I need to throw to pass it directly to Hannah? What we have here is a displacement problem that involves vector addition. When we add two vectors, we can depict this graphically by simply placing the tail of the second vector to the tip of the first. The sum of two vectors is called the resultant and can be obtained by commutative addition. This is simple enough when both vectors have the same direction regardless of magnitude, but in our problem, the vectors are completely unequal. If we were to find the net displacement of our two vectors, we must add them together to get the resultant, which stretches from the tail end of the first leg to the tip of the second. In our case, this would be equal to the path the frisbee would take to go from my dot to Hannah's dot. Note that because the two vectors are unequal, the magnitude and direction of the resultant is not equal to the sum of the two original vectors. Using the graphical method is handy when in a pinch, but if we want an accurate and precise way to solve for unknown quantities in vector triangles, we can use a neat technique involving trigonometry. But first, it's important to know that every vector can be seen as the resultant of two special component vectors that are projected onto the coordinate axis. If we were to find these vectors, we usually use a reference angle, which is the acute angle between the vector and its horizontal coordinate axis. Most physics problems use right triangles. So by using the trigonometric functions and the Pythagorean theorem, we can find the unknown variables of a vector triangle. The three trigonometric functions are the following. The sine of an angle is the ratio of the opposite side's length to the length of the hypotenuse. The cosine of an angle is the ratio of the length of the angle's adjacent side to the length of the hypotenuse. And finally, the tangent is the ratio of the opposite side's length to the length of the adjacent side. So let's try the first two ratios on this triangle. We only have the vector length and the reference angle. We'll first use sine to find Ly. We input our known variables into the formula and solve for the unknown variable. In our case, the y-axis projection is equal to 8 units. To solve for the x-axis projection, we need to use cosine. So we pretty much do the same thing. Plug in the known variables to the formula, and then we get our answer, which is 10 units. Once we finish, we get an equation that looks a bit like this. It's good to know how these formulas work if you only have a paper and pencil, but you'll probably end up using a calculator anyway. With all these tools at our disposal, how do we finally solve our initial problem? To find the magnitude of the unknown side, we use the Pythagorean theorem. We use a formula to solve the hypotenuse, add our variables, and finally simplify to get our magnitude, which is 11.66. Then we use the arctan function to calculate the reference angle. Plug the values into the formula, and finally simplify, and then we get our answer, which is 31 degrees. So to throw the frisbee directly to Hannah, I have to throw it 11.66 meters at 31 degrees northeast.